Namaste. Welcome to another algebraic expression session. Let's do a quick recap of what we have done so far. Let's do a quick recap now. Let's say the terms, right? Starting with the terms. We have like terms and unlike terms. So like terms have the same variable or they have the variable with the same power. So same variables and variables with same power or exponent. So they become like x squared, right? AB, right? So these are all some of the examples, right? Unlike terms will have basically different variables and different also, or maybe same variables but different exponents. So they will be like, something like, let's say x plus x squared is an example of an unlike term. So here it is an example of, say, let's say x plus x or an x squared plus x squared. It's a like term. Why is it important? Because in addition and subtraction, we can only add or subtract like terms. Okay. Next one is basically the degree of the variables. So the degree is basically the power or the exponent that the variable has. So let's say that this is x squared is a degree of 2, right? X cubed is a degree of 3, okay? Because when we multiply in this chapter, the degree, it plays a significant role. And now let's say that we are adding like terms. In addition and subtraction, as I said earlier, we can add only the like terms. And we can also multiply, or we can also subtract the like terms. So let's start today's session, that is multiplication of polynomials, multiplication of two or more algebraic expressions. Let's understand some rules. Let's go back to, let's revise a little bit on the laws of exponents. So remember, there is a power law, right? And then we don't really need that power law that much, but we use it. So that is when we have the multiply the two powers. So let's say that a to the power m, the whole power n, and we basically get that a to the power m and n. Then we have product law. So this is what we need here, the product law, that is the same base am times an. That means that the base is same, so we just add the exponents a m plus n. Then we have the quotient law. Here we have, let's say, am by an, and if m is greater than n, then we have am minus n. But we need the product law over here. So let's understand, since we are multiplying the algebraic expressions. So we're going to use, and if the variables uh, are same, then we use the product law, right? Let's now take a, okay, let's understand the types of expressions. Just do a quick review. So we have a monomial. So monomial is basically one term, correct? So it's just one term. So let's say that, 2x is one term. So now how do we multiply a monomial by a monomial? So let's say that I have, in arithmetic, we would have done 2 times 3 is equal to 6. Now 2 is a monomial term, it's a constant, and 3 is also a constant, so we get 6. Now if we just add a variable to it, let's say that 2x times 3x. The rule for that basically is, the product of two monomials will be the product of the numerical coefficients. So this is the numerical coefficients. And these are basically the variables, x. So what we do here is product of their numerical coefficients times product of the variable, right? So let's plug the values here. So product of the numericals, a numerical coefficient is 2 times 3, correct, times x times x. So it will be 2 times 3 is 6, x times x is x squared, right? X squared. So this is your product. This is basically the product of the two monomials. So when we multiply 2x times 3x, the result is 6x squared. Got it? Now let's do one more. Multiplication of a monomial by another monomial, right? Let's say I have negative 4a times 7a. Okay. So the product of the numerical coefficient is negative 4 times 7 times a times a. So negative 4, let's understand a little bit about the rules of signs here. When we multiply same rules, right? Let's say that I have the minus, or maybe let's take with plus times plus, I get a plus, I get basically a positive product, right? So same signs we multiply, we get a positive or a plus sign. So it's the same thing with negative. So negative times negative gives me positive, right? So we are multiplying same signs here, and we get a positive sign. And then we have different signs. Negative times positive gives me negative. And then a positive times negative gives me negative. This is called the rules of the sign. So here I have a negative 4 times positive 7. So now negative times positive will give me negative. And then let's say 4 times 7 will give me 28. So the product of the numerical coefficients negative 4 times positive 7 will give me negative 28. And I have a times a will give me a squared. So this is the product of two monomials, negative 4 times negative 4a times 7a. Let's take another one. I have 6xy times negative 3 x squared y cubed. Yeah, can you try this? Okay. So the product of these two monomials is the product of the numerical coefficient 6 times negative 3 multiplied by the product of the variables, that is x times x squared, and then I take another one, so let's say y times y cubed. Okay, so here is the plus sign. So the rules of the sign, say two different signs, positive times negative gives me negative. So negative 6 times 3, 18. So this is the product of the numerical coefficient. Now let's come to this. So I can see that the base is same for me. This is x. Remember, x means there is raised to the power 1, x to the power 1, right? So x to the power 1 times x to the power 2. Nothing but a to the power n times a to the power m, which gives me a to the power m plus n. Now let's understand a little bit. So x to the power 1 means that is 1x times x to the power 2 means x times x. Correct? So how many x's that I have here? I have 3. So can I say that x to the power 3? So similarly, x to the power 1 times x to the power 2 gives me x to the power 1 plus 2 is equal to x to the power 3. But the real solution is this. But we just take a shortcut. If the base is same, we just add the exponents. So x to the power 1 times x to the power 2 gives me x raised to the power 3. Now same thing, I have a y to the power 1 here. So I have y times y to the power 3 means y times y times y. So how many y's are getting multiplied here? So y is getting multiplied by itself 4 times. So y to the power 4. This is your product of 6xy times negative 3x squared y cubed. Got it? Let's take a slightly different problem. Say that I have a cuboid and I want to know the volume of this. That is how much of something it can hold. So the volume of a cuboid is, this, let's say this is the, this is the length, right? This is your height, right? And this is your basically the breadth. So the height actually is the volume of the cuboid is length. Maybe I'll just write it here. Is length times height times breadth, right? So this is the volume. So let's say that my length is say 20x, right? And I have my breadth is 3by, and I have my height is 5z. So what is the volume of this cuboid? So we know the volume is length times height times breadth. So let's plug in the value. The length is 20x times height is 5cz times breadth is 3by, right? So now we have to find the product of it. So the volume is nothing but the product of length times height times breadth. So the product of the numerical coefficients is 20 times 5 times 3, then multiplied by the product of the literal coefficients, that is the variables. So as I can see here, there's x times c times z times p times y. So all are basically, different variables. So we just multiply the numerical coefficients. So it is 5 times 10 is 5 times 20 is 100. 100 times 3 is 300. Right? And then x times c is xc. Xc times z is xcz. So we just just multiply them. So um, x, c, z, t, y. This is your volume of the cuboid. Got it? Yeah. Okay. Nice. Let's take uh, another one. Maybe uh, uh, let's say 4 by 9 a to the power 5 b to the power 2 is one term, multiply by another term, that is 10 a cubed b, and again multiplied by a third term, let's say constant 6. Let's give it a try and let me know how it goes. Okay, let's try. Multiply the numerical coefficients, that is 4 by 9 times 10 times 6. Correct? And then multiply the variables, that is a to the power 5 times a to the power 3 times b to the power 2 times b to the power 1. So that is b, and it is b to the power 1. So I have just grouped them now. I have to multiply. So remember, we are multiplying, whether you take it as fractions, whether you take it as rational numbers. The rule for multiplication is you multiply the numerator and you multiply the denominator. Let's assume that there is 1 over here. You don't need to really do that, and because it has got that multiplier effect that the product can be too big, we can, if we want to, take a common factor and cancel it out, right? So I can cancel out here. I can cancel out. Just a note on how we do the canceling of common factors. Just giving you an example. Let's say I have 2 by 5 times, let's say I have 15 by 4, right? You can see the way I write it. So we multiply the numerator. So 2 times 15 by 5 times 4. We multiply the numerator, we multiply the denominator. So if I have to do this, then I would just probably do 30 times 20, right? And it is cancel out 3 and 0 and 0. So it is 3 by 2. But we can cancel out, if this was just a small example, but I can cancel out 5 times, divide this by 5, so I get 1, divide this by 5, I get 3, divide this by 1, I get 2, divide this by 2, so I get 1, divide this by 2, I get 2, right? So this is a much better way to take out, the common factor and cancel out than doing multiplication. So we can only divide, diagonally, or we can uh, cancel out, or we can divide this way, because the division sign, remember, it is P by Q. So we can only divide this way. We can't, we multiply this way. We multiply this way. We divide this way. This is the notation, P by Q or P times Q. So now let's come to this. So I have a common factor. I can take a common factor. So that means that I can divide this one by 3. And I can divide this by 3. So what is it that I get? So 4 by 3, 9 times 9 divided by 3 is 3 times 10 times 2. So I have 60, because 4 times 10, 4 times 10 is 40. 40 times 2 is 80. This is 80 by 3 times a to the power 5 times a to the power 3 is a to the power 8. B to the power 2 times b to the power 1 is b to the power 3. Correct? So I can't do this. 80 by 3 is, I don't have a common factor. So we can just leave it at that if we want. Okay. Let's take another one. Okay. Just a slightly smaller one. Say I have negative 6 a squared bc times 2a squared b times negative 1 by 4. Can you try that? Okay. So multiply the numerical coefficients, that is negative 6 times 2 times negative 1 by 4, multiplied by a squared times a squared times b times c. So so it is negative into negative, so it gives me positive, right? And 6 times 12, 6 times 2 is 12, and negative 12 times negative 1 gives me 12 by 4, which is nothing but 3, because 12 divided by 4, okay, let me do that. Negative 6 times negative 2 times negative 1 divided by 4. So it is 12 by 4. So 12 divided by 4, that means 4 times what will give me 12, right? 4 times 4 times what will give me 12. So my quotient is 3. So because 4 times 3 is 12. So the product of this is 3. A squared plus a squared is a to the power 4. B times b is b to the power 2. And C as it is. So this is the right. It is positive, not negative, because negative times negative will give me positive, right? Okay. Now, so far you can see that we have multiplied two monomials, but algebraic expressions can be monomials, binomials, trinomials, and it can be in any of the combination. So now let's multiply. Let's try to multiply a binomial by a monomial. So what is that? Multiplication of a binomial by a monomial. Okay. So a binomial is basically has two terms, correct? So let's say, like for example, let's say I have b plus c. This is a binomial because it has got two terms, b and c. Now this is going to be multiplied by, let's say, a, and a is a monomial. So we distribute this. So distributive law. So let's understand a little bit about the distributive law. So I have a times b plus c. That means I just have to distribute a. So I can do this. It is in parentheses b plus c. So one way to do that is, let's say I take an example. I have 2 times, let's say, um, um, uh, let's say 3 plus 2. So you use your, the board mass, and then you say, simplify what is there within the parentheses or brackets. So you probably do 3 plus 2 is 5. So 2 times 5 is equal to 10. But the another way of doing this is I have in distributive law. So we have 2 times 3 plus 2. So what we do here is that, 2 times 3 plus times 2. It gives me the same result. 2 times 3 is 6 plus 2 times 2 is 4 is equal to 10. Right? So this is distributive law. Okay? So we just distribute. We just multiply in the individual. And in this multiplication of a binomial or, by a monomial, we can use two methods for multiplication. One is the horizontal method, like what I have taken. This is more horizontal method. Or I can take a column method. Right? So let's take an example. So this one is called as the multiplication of literals. Okay. Multiplication of literals actually is distributed over addition because there is an addition sign. Okay. And we can also have for subtraction also. Okay. Let's take an example. Let's say I have a monomial 4x. and then you multiply it with 5x is 6y, correct? So now one way to do the horizontal method, this is the horizontal method. The horizontal method we can do is 4x, we just distribute it. Horizontal is nothing but the distribution, correct? So 4x times 5x plus 4x times 6y, right? I can use it this way, or I can just say 4x times 5x plus 4x times 6y. Or I can also use 4x times 5x plus 4x I can do it that way also. So now whatever it is, so we are still multiplying it. So what is it that we get? So remember, I'm just giving you the stepwise. The whole concept of these classes is not to find answers, but to go through the process, go through the steps and enjoy it, understand the process rather than arriving at the answer. So this is all about learning, not finding the answer. So that should never be forgotten. So now multiply the numerical factors. 4 times 5 times x plus 4 times 6 times x. So now let's do the multiplication. 4 times 5 is 20. X times x is x squared plus 4 times 6, 24. X times x is x squared. Okay, so now we come to the addition now because we have an addition sign. Now we have to use our knowledge of whatever we have learned so far and apply it. So 20x squared plus 24x squared. Now, is it possible to add these two terms? Okay, then we need to understand, or we need to recollect that we can only add like terms, or we can subtract like terms. So can we add these two like terms? Are they like terms? Then where should we look? What is the test? 20, the numerical value is insignificant. We are not interested. What is the numerical value? Because we are doing algebraic terms. So that is why we always look at the variables. So are they, remember the like terms, either have the same variables or, yeah, they have same variables, or, and basic, I think I should say and, they should have the same exponents. So both are x squared, so both are like terms. So 20 plus 24 is 44x squared is the answer. Got it? Yeah. Got it? Okay. Let's take one more uh, multiplication of binomial by a monomial. Let's say I have a 3x minus 4 by 5 y squared x, right, multiplied by 1 by 2 xy. Okay. How do we do this? We can multiply or distribute 1 by 2 xy. So let's say 3x times 1 by 2 xy minus 4 by 5 y squared x times 1 by 2 xy, right? Same thing, multiply the numerical coefficients. So the numerical coefficients here are 3 and 1 by 2, and I have negative 4 by 5 times 1 by 2. So 3 times 1 by 2 is nothing but 3 1 by 2. Think that there is 1 over here. So multiply the numerator, multiply the denominator. So the multiply the numerator is 3 times 1, multiply the denominator is 1 times 2. So it is 3 by 2. Now x into x will give me x squared, correct? And then y. Got it? X into x is x squared and y is the lone variable, y. So then just y. Now let's go. So negative. So obviously it has to be negative. Now 4 by 5. So let me expand this a bit. So 4 by 5 times 1 by 2, correct? Times y squared x times xy. Okay, let's do this. I can take out the common factor, that is 2 times 1, 2 times 2, right? So I have here 3 by 2x squared y minus, so now this is 2 by 5. X squared times x is x cubed. This is the one I'm talking about, x squared times x, right? And then x times x will give me x squared. This is your product, right? Let's take the column method. You may find this useful, the column method. And let's take the same example, that is 3x minus 4, right? I have 3x minus 4y, that is negative 4 by 5 y squared x. I'm going to multiply this. I'm going to multiply this by 1 by 2 xy. Okay, it's a very simple one. Okay, the first step is 3x times 1 by 2 xy. So first I do this, and then second I do this. Okay, so do this one, first one, then I do the second one. Okay, so this will be, so it will be negative 4 by 5 x squared y. This is, let's say this is first step, and this is your second step. So negative 4 by 5 y squared x times 1 by 2 xy. So 3x times 1 is 3x, 3x times xy is 3x squared, right? 3 by 2 x squared y. Then I have minus 4, that is negative 4, and then I have a common factor here. So I get 2, right? I have a negative 2 there, sorry. So I have negative 2 by 5. Y squared y is y cubed. X times x is x squared. This is your answer. Okay. So that's about it for today. If you have any questions for this session, you can ask me in the class. And tomorrow we will continue with multiplication. Now, multiplication of two binomials. We can we take up multiplication of two polynomials, and then maybe algebraic identities if time permits. Okay. Thank you and have a good day. Bye.